We're going to be continuing from where we left it. Remember, the last lesson we talked about asset security. So in this lesson, we're going to be taking a look at security architecture and engineering. I know that the first lesson, when I was defining this very topic, I told you that this topic has to do with seeing if we can come up with standards, just like we do in engineering, standards that can help us to effectively implement security within the organization. And this is exactly what this particular lesson would focus on. So here we're going to be talking about what we refer to as architectural frameworks, and then also talk about security models. Aside from that, we shall also talk about evaluation criteria, then system security architecture, as well as what we refer to as distributed systems. These are the things we're going to be taking a look at in this very lesson. So I'll talk about security architecture. We're going to take a look at architecture frameworks, things like TOGAF, that's the Open Group Architecture Framework, a Zachman framework, and a host of others. A good architecture framework, of course, would ensure that security considerations are built into the core of the system. Then also, talking about security models are more like frameworks that define how security policies should be implemented. Some very popular security models include Bell-LaPadula model, Biba integrity model, Clark-Wilson model. We'll see all of that. The models are also very important because they help us to structure how we're going to be creating access controls, data flows in the organization, then also other critical security mechanisms within the organization. We shall also talk about evaluation criteria like the CISSP, then also systems architecture as well as security architecture, and then, of course, distributed systems. But before we proceed, let's take a look at this particular case study. Kevin Butler, security administrator at the Network Firewalls Division at Notary Worldwide Inc., read the internal case study on security architecture and design. In the last financial year, Notary Worldwide Inc. expected a large increase in IT infrastructure requirements. The management felt the need to implement best practices for IT service management. Hilda Jacob, the general manager of IT security, was assigned the task of selecting the best framework to help the organization identify, plan, deliver, and support IT services. Hilda decided to select the ITIL framework. So this case study more or less talks about the importance of using standards frameworks, especially when it comes to implementing processes and functions within your organization. If you notice, there are a lot of frameworks and standards out there. So faced with this situation, what did Hilda Jacobs do? She adopted an existing framework. And this is the ITIL framework. Because ITIL is basically IT service management. So since what we're doing is to be able to determine best practices for IT services, and there's already a framework in place, why not use it? So that's the summary of this case study, that as a security professional, it's also necessary that if you want to implement security within the organization, you want to adopt certain security measures within the organization, it may be necessary you take a look at the various frameworks, because beyond the scope of the CISSP, you can study these frameworks, the likes of COBIT, ITIL, and then, of course, TOGAF, and the rest of them, and see the one that you can adopt, especially within your organization, that will help you meet your organization's objectives, need, as well as goal. So talking about security engineering plays a major role, especially as it pertains to development and protection of information systems. I gave an example of how engineering is quite important. Some of the importance of security engineering would include building information systems as well as related architecture. Security engineering is very, very important in the design and the development of secure information systems because it makes sure that security is an integral part of the system architecture. So in essence, security is integrated during the development of our systems architecture from inception instead of being an afterthought. So let's say, for example, if we're designing a financial system, you can have security engineers and then, of course, ensure that we implement relevant data encryption, access controls, access restrictions, as the case may be, and also design a system that is resolute. and can handle potential threats like cyber attacks from inception. So you don't want a situation where the financial system is designed, then it is when we're now hit by an attack that we now start looking for what we can do in order to solve the situation and make sure that maybe it doesn't happen again. So, but if you're building it in from inception, it becomes a built-in thing and it's part of the development process. And that's one of the key things that security engineering helps to accomplish. Also, delivering functionality to address threats to information systems. So security engineering also will make sure that systems have the necessary functionality to counteract or mitigate security threats. For example, integrating security measures like authentication, firewalls, intrusion detection systems in order to protect the system from unauthorized access or data breaches. So let's say, for example, we're doing a web application. For the web application, we may use multi-factor authentication to ensure that only authorized users can access certain data, then also provide an additional layer of security. All of these are part of what we can achieve in terms of delivering functionality and addressing threats to information systems. Also, incorporating security controls, capabilities, and behavior into enterprise architecture. So again, security engineering will help us to integrate security controls and behavior into the broader enterprise architecture. So this will make sure that security is embedded in every aspect of the system. One of the key things we took a look at earlier on, we said that as much as possible, when we're talking about characteristics of information security policy, we mentioned it should integrate every aspect of the organization into it. So a key way to do that is via security engineering, because this will now help us to ensure that every aspect, security is integrated into every aspect of the systems and functions within the organization, including how the users interact with the system, how the system responds to threats. All of these things are part of the key things that security engineering will help us accomplish. Think of, say, we are building an e-commerce system. We need to incorporate security behaviors, meaning that we need to enforce least privilege access, making sure that only users that have access can have access to payment or customers' data, as the case may be. Aside from that, security engineering can also help us in addressing principles of confidentiality, integrity, as well as availability, which of course is at the core of information security. Confidentiality, ensuring that sensitive information is accessible only to authorized users. Integrity, making sure that information is, as well as resources are available. Integrity, making sure that information remains accurate and unauthorized, or rather unaltered by unauthorized individuals. Then availability, where we talked about ensuring that information and resources are available to authorized users when needed. So these are some of the key things that proper security engineering actually helps us to accomplish. So we cannot overemphasize the importance of security engineering because, as you can see from the examples we've cited, it takes security from the development stage and then also ensures proper security throughout the life cycle of the organization. So it's involved in the system in every day-to-day working of our organization. This will, of course, help in protecting both personal as well as other information that we have within the organization. So to be able to effectively implement security using security engineering, remember we said there are a couple of frameworks. A framework basically would help us to be able to design and manage complex systems within the organization. And we have various architectural frameworks. So if we talk about architectural framework, an architectural framework establishes a common practice for creating, interpreting, analyzing, and using architecture descriptions within a particular domain of application or stakeholder community. So in essence, it helps us to standardize how systems are built, ensuring they are aligned with the organizational goal, and then also can be scaled effectively. So these are some of the features of an architecture framework. One, it's a method for designing a target state as an integrated set of systems or systems component. Simply put, architecture frameworks provide us a structured approach for designing systems in alignment with the organization's target goals. It will help us to integrate different system components to create a cohesive, functional system. Let's say, for example, in an organization, the architecture framework can guide us as to how various applications like HR, finance, CRM systems, how they all work together to meet the organization's goals. The architecture framework also provide a set of tools to ease architecture development. The framework can offer us tools and methodologies that can help the architects develop as well as visualize and implement complex systems effectively. Tools for modeling software, templates, all of these allow architects to plan and document system components, especially as it pertains to the organization. Architecture framework also provides us with a common vocabulary. So it standardizes different terminologies that we use in the organization, making sure that everyone uses the same language when discussing system designs as well as operations. Of course, what this will do is that it will reduce misunderstanding as well as miscommunication. So in systems, you're talking about things like maybe a data layer, business process, integration layer, making sure that all of these terms have consistent meanings across teams within the organization itself. It also includes a set of recommended standards as well as operational practices. So the framework suggests or enforces certain standards and best practices that ensures the integrity as well as security and performance of our system. Then also includes information on design elements within the framework. All of these are some of the key things that architecture framework actually helps us to accomplish, or architecture frameworks helps us to achieve. So if we now take a look at some very popular architectural framework that we may choose to adopt within the organization, one of the very popular architectural framework that we're going to be talking about is what we refer to as the Zachman framework. Zachman framework. So the Zachman framework provides us 36 ways to completely define anything. And that's why we mentioned that the Zachman framework is a comprehensive representation of an information enterprise. It is arguably one of the most popular and well-known architecture framework. But one of the key things that the Zachman framework does is that it helps us organize and structure complex systems. So that's why I mentioned that the way it works is, one, comprehensive representation of information enterprise. So the Zachman framework will offer a structured view of an entire enterprise architecture, including business processes, technology. So it will capture all the necessary aspects of an organization's architecture. This will now make it easier to manage and understand complex systems. It is a two-dimensional classification matrix. Two-dimensional classification matrix simply means that the framework is presented in a two-dimensional format, which are the vertical dimension as well as the horizontal dimension. So this horizontal dimension will represent the functional questions. That's why you're seeing it here, the what, the how, then the where, who, when, and why. By the vertical dimension will represent the stakeholders that are involved. For example, the planner, owner, designer, builder, subcontractor, functioning enterprise. The Zachman framework is not a methodology. In other words, unlike other frameworks, the Zachman framework is not prescriptive. It doesn't dictate specific processes or methodologies for how to design systems. But then we can use it as a tool to help organize our architectural artifacts. Then it also does not imply any specific method or process. Since it's not a methodology, it means that the framework is flexible. So it can be used with any other architectural framework. For example, TOGAF, Agile, and other architectural frameworks. So the key thing that Zachman framework does is it focuses on categorizing and understanding the architecture rather than prescribing how to implement it. It's a schema for organizing architectural artifacts. So Zachman framework serves as a scheme, or more like a structure, to enable us categorize and organize artifacts. So it's more like a model or a diagram associated with enterprise architecture. So this makes it easier to manage and communicate complexities of systems as well as designs. So if we take a look at this, you see this is a typical example of Zachman framework. So say, for example, the planner, if you talk about the what, you talk about what the planner needs to know. Then also what the business objectives and what resources are available. Then for the designer, how the designer figures out how the system will be implemented, focusing on technology aspects. The builder now determines the where. So this person focuses on where the system components will reside. whether it will be in the cloud or in the servers or reside on premises, as the case may be. Beyond the Zachman framework, there's also the Open Group Architectural Framework, which of course, for short, is usually referred to as the TOGAF framework. This is owned by the Open Group. That's why it's called the Open Group Architectural Framework. It's an enterprise architecture framework. It provides us a comprehensive approach for designing, planning, as well as implementing and governing. It is a trademark of the Open Group. It's also a high-level and holistic approach to design, and is modeled at 4 levels: business, application, data, as well as technology. TOGAF is arguably one of the most widely used enterprise architecture framework. More or less gives us a structured approach for designing, planning, implementing, as well as governing enterprise architecture. So some of the key points about the TOGAF is basically that it can be a framework that can be used by the organization for designing and managing their enterprise architecture. And then it also gives us a comprehensive approach for designing, implementing, as well as governing our enterprise architecture. Aside from that, we mentioned that there are 4 major aspects or 4 major levels, which are the business architecture. So the business architecture usually defines the business strategy. So the business strategy is more or less our choosing course of action. Then there's the application architecture. This outlines things like our software applications and their relationship to the business processes. Then data architecture. This defines the structure of an organization's data assets, as well as our data management resources. Then, of course, technology architecture that now talks about hardware, software, and network infrastructure. So if you take a look at this cycle, this consists of the several phases that make sure that enterprise architecture is designed, implemented, and managed properly. So in essence, it gives you a cycle. If you want to design and effectively implement and manage your enterprise architecture, TOGAF basically gives you a cycle that you can follow. You can see at the preliminary stage, preliminary phase basically is where you lay the foundation for your architectural project, including defining the principle and the scope of your enterprise architecture. So within this, we now have what we call our architecture vision. Architecture vision, they will define the vision of the architecture. Basically meaning that before we start designing our enterprise architecture, we need to establish the vision and make sure that it aligns with the business goals. And then we now talk about the business architecture. So this will now focus on creating detailed view of the business processes and how they interact. Then information systems architecture. This, of course, will include data architecture and application architecture. Then, of course, you talk about technology architecture. This will now outline the technology infrastructure that will support the business, as well as information systems architecture. Then opportunities and solutions. So this will help identify and evaluate potential solutions for the architecture. Then migration planning. So here you develop a roadmap that you will use to transit from the current architecture to the target architecture. Then implementation as well as governance. So you now ensure that the architecture is implemented in alignment with the plan and then also meets the goal for which it was designed to accomplish. Then the last stage is architecture change management. So the architecture change management will now deal with managing changes to the architecture in order to make sure it's aligned with the business needs. Then within this circle, you now see the requirements management. So you notice that it is central to all of these phases, making sure that the architecture meets the organization's needs as well as goals. So in summary, if you take a look at what's happening here, you can see TOGAF is simply saying that if you follow this step-by-step approach from start to finish, by the time you're done, you would have been able to design, not just design, implement, and then also be able to manage your enterprise architecture. From when you envision it to when you begin to determine what will be your business architecture. In other words, your processes and functions, your information systems architecture. In other words, things you're going to be using, for example, computers and how you manage information within the organization, your technology architecture. We can now talk about technological tools that you will need that will enable you to support the business. You talk about your servers, data centers. Then you now consider solutions that can help you do all of these things. You put in place your business architecture, that's your business processes and all. your information systems and your technology in line with the architecture vision. So once you've evaluated, solutions can now be ERPs, it can be implementing series of processes, management systems, as the case may be. Then you now put a plan in place for how to actualize it. Then you do the implementation. Then, of course, subsequently, if there's not going to be any change, maybe in any of these architectures, you follow through a change management process that is also captured within that particular architectural design, all making sure that you're constantly meeting the requirements of the organization. So TOGAF is very practicable. Unlike Zachman model, TOGAF actually gives you a structured, implementable, step-by-step approach that you can actually take, especially when implementing architecture, enterprise architecture within your organization. Beyond TOGAF, there's also the ITIL. ITIL is a very popular framework, although we have a recent version. But then the whole message of the ITIL framework, again, similar to what you have in TOGAF, ITIL gives you more steps that you can follow to effectively implement IT service management, especially within the organization. So if you notice, within the ITIL framework, ITIL has different phases, which include service strategy, service design, service transition, service operation, and then continual service improvement. Service strategy is simply saying that if you need to come up with an IT service, you need to first of all determine the why. That's the justification for it. So you come up with a strategy for your IT services and make sure that they align with your business goal. Then after the service strategy, the next stage is now your service design. This is where you now provide guidelines, and then you now come up with your IT services. You design your IT services. For example, processes, infrastructure, resources, making sure that they meet current and future business needs. Then there's now the service transition. So you notice you've talked about the why under the strategy. You've talked about the how under the design. During the service transition, this is now where you talk about dealing with managing changes to services, including building, testing, and transitioning services into live environment. Here you create those services, you manage them, then also you transit and test. Then there's now service operation. Service operation now focuses on the day-to-day support and management of the service itself. So let's say, for example, we want to deploy a new service as an IT service. We want to offer, let's say, paid TV subscription. We're not just going to jump into the service because it's looking like DSTV is making a lot of money. We also need to determine the strategy, the justification, the why, what will make people buy, what will make people leave DSTV, for example, and subscribe to our own. All of that is what you do on that service strategy. Once we've done that, we now design the service. Would it be a subscription-based? Would it be pay-as-you-go? Would it be, the various bouquets and how many channels one can access based on his bouquet and all that? That's what you figure out during the service design. Then service transition is now where you start developing those services, start implementing them, and start managing them. Of course, once we roll it out, what happens? We need to now constantly support it to make sure that they stay available. You don't want someone subscribes for a particular bouquet and the person is not able to access it, for example. If that happens, the person should be able to reach to us. And then we have a help desk that can assist. Or maybe there's a downtime somewhere in one of our services. So in essence, service operation from the word operation is where we constantly ensure availability of our service and make sure that the operation is ongoing, continuous, as well as constantly available. And that's basically where service operation comes in. In all of this, you should ensure what we now call the CSI, continual service improvement, meaning across all of these phases of your IT service management life cycle, you should always be asking yourself, how can we do better? Or how can we improve on our IT service delivery? There's also the SAPSA framework. This is also another architectural framework. The SAPSA framework is basically, SAPSA stands for Sherwood Applied Business Security Architecture Framework. So this is a model and a methodology for developing risk-driven enterprise information security framework. So in a nutshell, it uses what we call risk-driven approach, because SAPSA focuses on identifying and mitigating risk to an organization based on the specific business requirement. So this means that the security measures are directly derived from the risk that the business faces. So in essence, SAPSA makes it more targeted and then also something much more effective. Aside from that, the primary characteristics is that everything must be derived from the business requirement for security. More or less what I've said before. In essence, everything starts with the business requirement for security. So this ensures that security is not treated as an isolated function, but then is embedded into the whole business strategy. So if, for example, we're a financial institution and we need strong data confidentiality for customer transactions, so SAPSA will guide us as to how to implement encryption access controls based on this very requirement. Then also the process analyzes the business requirement at the outset and creates a chain of traceability. Chain of traceability from the business requirements through to the implementation of the security controls. So this allows the organization to see how each security measure relates back to the original business needs. So if you take a look at the SAPSA framework, you notice that it has 6 layers, which of course include contextual, conceptual, logical, physical, component, and operation. So the contextual layer focuses on the business context. So it asks, what are the business requirements for security? So if you understand the organization's goal and business, this of course will now help us to be able to determine measures we can take to be able to protect the business. Then also, conceptual basically translates the business requirement into what we now refer to as high-level security concept. For example, defining the overall security objectives, like ensuring data confidentiality and integrity. Then the logical layer will now create logical designs for security, like defining access control policies, network architecture. The physical layer will now focus on the physical implementation of security architecture. Then also, the component layer will now involve detailed component design. Operational layer now handles the day-to-day operation of security measures. So all of these layers, if well implemented, would help us to be able to meet the security need of the organization. And that's also another very popular architectural framework, which is what we call the SAPSA model. So we are taking a look at various architectural frameworks. Next, we're going to talk about security models. Security models basically now talks about the rules that, if implemented, can support our enforcement of a security policy within the organization. So they are used to determine how security will be implemented, what can access the information systems that we have, what can they have access to, and then in what ways can they have access to it. So for you as a security professional, you should be aware of the general types of models that we have. We're going to take a look at a couple of them, site-specific examples, also goal for addressing, those security models, as well as how each of these models builds on an earlier model. All of these things are part of the things that we're going to be taking a look at even as we journey along. But the key thing you should understand about security model is that they give us more like a step-by-step approach that we can adopt to enable us effectively implement security within the organization. So some of the very popular security models that we have, of course, include, we have what we refer to as the state machine model. So the state machine model describes the behavior of a system. It describes a system at a point of time and defines which actions will be permitted. If, for example, if any component of the operating system or the firewall fails, it must fail to a secure state. And this is one of the key things that the state machine model focuses on. So in essence, it helps us to monitor the status of the system to prevent it from slipping into an insecure state. It also shows us the current state of the machine and what could happen next. And that's essentially what the state machine model focuses on. The state machine model helps us to determine how a system behaves in various states. So if you take a look at the diagram, you can see the various states there. So the circle represents the states. Those are the various states of the system, such as opened and then also closed. Then you see the transitions. So the arrow shows how the systems move between states based on the actions. For example, opening and closing. So you also notice we now have what we call transition conditions. So in a nutshell, these are more like the rules that dictate when the system can transition from one state to another. For example, a door can only be closed if it's currently open. So that's essentially what this is saying. Then there's also what we call the multi-level models. Multi-level models are security models that describe strict layers of subjects as well as objects and define clear rules, often described using lattices and discrete layers. So say, for example, a user with secret clearance can view documents at confidential and secret levels, however, not at top secret level. The multi-level lattice models helps us to determine the flow of information. That's what this actually talks about, so that we determine what information a user can have access to, especially within the organization. So typical examples of such multi-level models can include, we have what we call Bell-LaPadula confidentiality model. This will show flow of information. So if you take a look at this particular security model, it's called confidentiality model. In other words, if your goal is to ensure information confidentiality, which is the first part of the CIA in the organization, you may choose to implement the Bell-LaPadula confidentiality model. That's why we mentioned that it is focused on maintaining the confidentiality of objects. So these are the rules that we have in Bell-LaPadula. Bell-LaPadula is more or less the person who came up with this model. So it's actually someone's name. So we have what we call the simple security rule. The simple security rule states that a subject cannot read data at a higher security level. That's what we refer to as no reader. So this is a higher security level, this is a mid security level, and this is a low security level. What Bell-LaPadula is simply saying is that someone at this level should not read information that is available to people at this level. That's what we refer to as no reader. In essence, the information is higher than the person's security clearance or security level. So we call it no reader. We can see it protects confidentiality. So if, for example, the person on this level, based on our information classification, can access public as well as private information. The person at this level can access, let's say, sensitive information, and then, maybe sensitive information. Then the person at this level can access confidential information. So what Bell-LaPadula is saying is that the person at this level should not access those sensitive information, while the person at the level of sensitive information should not access confidential information. So you can see with that, it maintains confidentiality. That confidentiality principle, remember, states that information should be available only to those who are authorized to have access to it. So if you want to ensure confidentiality within your organization, consider implementing Bell-LaPadula model. There's also a property rule that the subject cannot write data to an object at a lower security level, which is more like the opposite of what we have said before, or saying the same thing, but then in a different way. If this person, level 2, cannot read what is in level 1, it means that whatever the person in level 1 writes should not be read by someone at a lower level. That's basically what the property rule is saying. The subject cannot write data to an object at a lower security level. There's now the strong star property rule, simply saying that a subject can perform read and write functions only to the objects at its same security level. It means that this person at level 2 can only perform read and write function only at this level. So you can see the focus is on confidentiality. We also have the Biba integrity model. Again, this is also another integrity model that came from Biba. Biba is the name of the person who came up with this. Biba is saying, if your information security goal in your organization is to enhance integrity. Remember, Bell-LaPadula is saying, if your own goal is to enhance confidentiality, use this in crafting your security policy. But then if your primary goal is integrity, Biba is saying, you may consider this rule. It's called the Biba integrity model. And the goal is to protect integrity of information. Again, it has the following rule, the simple integrity axiom. which says that a subject cannot read data at a lower integrity level, or what we call no read down. Cannot read something lower than you. So it means that a subject cannot read documents below his level. So this is called no read down. Then there's a star integrity axiom, which says that a subject cannot modify an object in a higher integrity level, which is called no write up. What does this mean? A typical example is the Tibetan monks. So you have the priests, you have the monks, then maybe you now have the lay faithful or the laymen, as the case may be. So when I was studying about the Tibetan monks, I noticed that a priest cannot read what a monk writes. A monk cannot read what a lay faithful writes. That's what we call no read down. The simple explanation is, for you to be a priest, you've transcended this level. So you are at a higher pedestal. So in order not to mess up with your knowledge, you can see it's protecting integrity, data integrity. You cannot read down. You cannot read what someone at a lower level writes, because you are at a higher clearance or a higher security level, as the case may be. The same way a monk cannot read what a lay faithful writes, in order to also maintain his own sanctity or to maintain his own data security, as the case may be. So that's the idea of no read down. Then also, that the subject cannot modify an object at a higher integrity level. So meaning that you cannot go and modify something that is above your own level. That's what we now refer to as no write-up. So all of these are very important if the goal, like I mentioned, is to maintain integrity. Then there's now the Clark-Wilson integrity model, which also focuses on integrity, but then at the transaction level. And it's very useful in commercial environments where data integrity is very important. So the Clark-Wilson model focuses on integrity at the transaction level, meaning that the model ensures that data is protected from unauthorized changes and then maintains integrity throughout the various transactions. There are three major goals of integrity. One, to prevent corruption of data. So information integrity is maintained by making sure that we prevent corruption of data items, maybe due to human errors. Then also integrity policy. Clark-Wilson model basically describes integrity policies that specify how data should remain valid and consistent. And then aside from that, auditing is also required, making sure that as much as possible, we carry out audits. It makes audit a major requirement in order to track all transactions that have been taken within the system. So this ensures all of these are various security models that you may choose to implement within the organization. So we're taking a look at architecture frameworks. We're also taking a look at security models. And next, we'll talk about evaluation criteria. Evaluation criteria basically are things we use to measure. Evaluation is more like a measurement system. So this is what we use to measure to be able to determine key indicators. For example, how secure a system is. So that's one of the key things that evaluation criteria measures. So they are used to measure real-world security of systems and products. And they can help organizations to choose products that meet their security standards. Evaluation criteria also help to provide assurance about the level of security that the product can offer. So if for example, you want to buy a particular IT equipment or product, you want to find out about the security rating. And that's one of the key things that evaluation criteria helps us to do. So there are a series of evaluation criteria and also bodies responsible for some of those evaluation criteria. We'll take a look at some very popular evaluation criteria. One, of course, is the TCSEC. TCSEC, of course, stands for Trusted Computer System Evaluation Criteria. So this was developed by the US Department of Defense in the 1980s, and it has different ratings. So these are the various ratings. How in airport you have category A, category B, and all that. So more or less showing the how secure and safe that particular airport is. So those are more or less just to give you an idea of these various ratings. So you have verified protection. So you have what we call A1 verified. A1 verified is the highest level of assurance that TCSEC can give. So it means that the system design has been formally verified. and that all aspects of the system security has been thoroughly reviewed and tested. So in essence, if you have a system with an A1 rating, it means that this system has high assurance, a high standard, is designed for within an environment that is secure and protected, and then is also guaranteed to a reasonable extent to protect sensitive data, especially in critical situations used majorly for military systems. Then there's also category B, which is mandatory protection, where you have B1, B2, and B3. B1 basically focuses on mandatory access controls. So this is where access decisions are made based on security levels. Then B2, more like structured protection. So this level basically introduces what we call structured protection beyond the B1. Is a stricter access control. Then the B3, this is also another level of control that ensures isolation of your security domains. Then the C is now referred to as discretionary protection. Again, you have C1 and C2. D is now the minimal security. So this is the lowest level of security. This is usually assigned to systems that don't meet any higher level security at all. So if any system at all that doesn't meet any of those higher levels is usually classified as D, it simply means that that particular system may have vulnerabilities and doesn't meet some of these security standards or requirements. There are also other evaluation criteria. There's the ITSEC evaluation criteria, which of course addresses confidentiality, integrity, and availability, whereas CISSP evaluates only confidentiality. So ITSEC, they do not prescribe security requirements. So they provide us two sets of levels that are evaluated separately, which are functional as well as assurance. So functional levels can range from F1 to F10, while assurance levels can range from E1 to E6. So in a nutshell, if you need something more holistic that covers the CIA triad, then you may now want to consider the ITSEC as the case may be. Functional levels. Functional levels, basically, they assess how well the system functions in terms of security. That's what functional level does. So the higher the level, it means the more secure the system is, or the more advanced the system is in terms of reliability when it comes to security function. While assurance level measures the confidence that the system security control will perform as intended. In essence, that it's going to keep performing. The higher level simply means that, yes, it has gone through rigorous testing and verification and has been tested and trusted. So E6 is higher than 5, higher than 4, higher than 3. Those are the various ratings. Then there's also the common criteria. Common criteria, also known as CC, is also an international set of specifications. Of course, this was put in place by ISO IEC 15408. The essence of the CC is to now integrate these various evaluation criteria into a common criteria for assessing the various levels of security for a system. Again, it has different levels, EAL 1, 2, 3, up to 7. EAL 1 means functionally tested, 2 means structurally tested, methodically tested, and on and on and on. So beyond this certificate, beyond this acceptance certification evaluation, beyond these evaluation criteria, some other things you also may need to be on the lookout for, especially when it comes to information systems, would also include certification and accreditation. You know how, let's say you want to buy water, and then you're looking for the NAFDAC number. That's a typical example of accreditation. So you have a body that has, or rather certification, you have a body that has certified that yes, the water is clean for consumption. Now, accreditation is now where we constantly keep coming to check. That's what accreditation does. So that's why I would say certification is the process of evaluating a system's architecture, design, and controls according to established evaluation criteria. While accreditation is the formal management decision to approve the use of a certified system. So again, there are various accreditations and certification standards that are out there, like the FISMA, the DISCAP, the DIACAP, the NIACAP, the DCI D63. All of these are various certification and accreditation bodies that, of course, can help in certifying IT systems. That helps us to also make informed decisions as to their level of security and how well they can meet our security needs, especially within the organization itself. So based on all of this that we have talked about, it is necessary that we bear in mind that all of these things are typically designed in order to help us to effectively address threats that usually comes, especially from an IT environment. Threats as well as vulnerabilities. These are some of the very popular vulnerabilities and threats. They include things like your covert channel, your viruses, then your rootkits, malicious codes, your backdoors, time of check and time of use. All of these are all the various vulnerabilities or threats that you usually face within a system's environment. Therefore, mitigation measures are usually implemented to deal with these threats. For web-based vulnerabilities, mitigation measures can include extensible markup language, then also security assertion markup language. Aside from that, client-based vulnerabilities for mobile devices and desktops. So you need to ensure that the security is designed assuming that the client system is infected. How you go to a hospital and let's say the doctor wants to attend to the individual. You see them, they will kit up, wear hand gloves and do this. The reason is because they treat each person as an infected individual. And that's why they need to protect themselves. So the same way, if you have a situation where laptops or thin clients, one of the key things is to assess them from a conservative perspective or from a doubt perspective. So if somebody gives you a flash drive or comes with a system, treat it as that the system is infected and then take measures in order to ensure that as much as possible, the infection doesn't transfer into your system or your network. Same also with mobile devices. So if you have an organization where people use their mobile devices, this is known as the BYOD, bring your own device. Again, ensure that there's proper policy in place for BYOD, and then also proper security measures, including technical security controls are implemented to address threats that may come with personal devices. Some of the best practices, of course, would include process isolation, data hiding, abstraction, or using cryptographic protection. Cryptography cannot be overemphasized, encryption, and the rest of it. Beyond this, physical security is also very, very important, especially as it pertains to security engineering. So it also means that we should also design our physical facility in such a way as to also enhance security. Security against some of these elements like natural disaster, supply system issue, man-made issues, or politically motivated issues. So you need to consider what we call site crime prevention through what we call environmental design, CPED, crime prevention through environmental design. If you ever go to a police, or rather, if you ever went to a barracks, notice that it's usually not a straight drive in and drive out. They will put some barriers here, some another one there, and then you now come, you go and turn at a particular roundabout, and then you meet another barrier. Reason is CPED, crime prevention through environmental design. They're making it possible for crime. And that's why they design the environment in such way. So certain criteria you need to put into consideration. Treat your physical security using what we call the layered approach. Layered approach would, of course, help you to ensure that you are taking care of each layer very well. And as much as possible, addressing it on a layer-to-layer basis will help you to structure your security, especially your physical security. So that's why we mentioned that physical security is an essential part of a security plan and forms the basis of all other security measures, including personnel and information. Every other thing we have said here, don't forget, they are all governed by physical security. If all this drama I've been speaking about protecting information system, there's a bomb explosion in our office, for example, maybe everything will crumble. All the information system that we're talking about, they will get blown away. So you can see why physical security is absolutely necessary, because most things are, embedded within our physical space. The people, infrastructure, assets, they are all within the physical space, and therefore that's why physical security is very necessary. So the most important goal is planning a site is protection of life I mentioned this earlier on, especially in our previous session, that life is one of the primary objectives of your physical security and, of course, altogether information security, property, and then operations. So it is the standard operational procedure for security professional to review all aspects of construction. So as a security professional, you need to take care or take a look at all aspects of construction and make sure that they meet requirements. Layered approach is a strategy that includes examining physical security measures starting at the site perimeter and working down to the desktop computer. Site perimeter, that's the fence, Abby. Then the ground, the building grounds, the compound. Check the security across the compound. Then the building entrances, the doors, because any opening within a building is a potential vulnerability. So that's why you check the doors, the windows, to find out how secure they are. Are they safe and foolproof? Then the building floors, again, within the building floors, how secure? There have been instances of people who bought tunnels. Aside from that, again, are they being monitored? Then, of course, the offices, data centers, and equipment, your supplies, your media, talking about computers and storage devices, network equipment. All of these are part of the things that you typically check using what we call layered approach. So I mentioned earlier on that you should consider what we call crime prevention through environmental design. Other things you need to put into consideration for your physical security is your site location. This is also very important, construction, and then other support facilities like your heating, ventilation, air conditioning, as well as fire equipment. So when we talk about crime prevention through environmental design, we're basically saying design your environment in such a way to help in preventing crime. And that's what this is basically saying. There are three major strategies. Territoriality. This will make users feel safe and make the potential offender aware of a substantial risk of apprehension. Surveillance. It creates the perception that the people can be seen. Access control, which limits the opportunity for crime. Territoriality simply means we should have presence, especially within the facility, and ensure that we implement security features within the facility so that when people come in the facility, they feel safe. That's essentially the idea of territoriality. This, of course, will include the site location where you've decided to site it. If you go and site your office in a place that is crime-prone, for example, it is against territoriality because when people are coming there, they don't feel safe. Or even within that area, the place is just open. No protection, no fencing, for example, or no proper access control. People can walk in, walk out. Again, it creates the impression that the place is not safe. So the idea of territoriality is ensure you site your location and also organize it and structure it in such a way that when someone comes in, they can have a breather and say, okay. Then surveillance, create the perception that people are being seen. This can also help in reducing crime. One time I was in Dubai, and one key thing I noticed is everywhere you go, CCTV camera. Even in small kiosks that all these Lebanese sell fruits and groceries. So when I needed to buy something, so I went to one of those stores and I saw about 7 cameras, one small kiosk like that. So I was asking the guy, what is all this? What are you? He now started laughing. He said that they are dummy cameras, but that it helps to scare people in case people want to be nefarious. Well, I don't know whether he was telling me the truth or not, whether it's dummy camera or not. But CCTV camera creates that surveillance perception. And if you have a perception that you can be seen, of course, it can discourage the attacker from doing some kind of things. Proper lighting, CCTV camera, all of these are part of the things that can do that. Then implementing access control, which of course will limit the opportunity for crime. Then for your site location, these are things you need to put into consideration. Location and access. How accessible is the place? This is very important. You don't want to site your location that in a place where it's not accessible. Accessibility could be maybe a very poor infrastructure, road network, or very poor planning. All of these are part of the things that location and access talks about. Then what is the local crime rate in that area? In terms of visibility, you're basically saying, how monitored is that place? Who sees what's happening there? There was one time in Port Harcourt, there was this guy, dispatch rider, that back in the years, though, now iPhone even has version 16. That was back in the years when during the time of iPhone 6, iPhone 7. So that's how those boys, they ordered for, I think, 2 iPhones from Jumia. So the Jumia delivery guy now went to deliver. They told the guy to enter the compound, lock the gate, kill the guy because of 2 iPhones, iPhone 6, that is now like water everywhere. They killed the guy, threw him into the septic tank, and took the iPhone. What gave the guy them away was somebody was seen from the other compound. So it was the guy who saw what happened from the other compound and now called the police. And then the police now came. So they're asking the guy, where's the delivery? They said, no delivery. Police said they saw the guy's bike parked somewhere. And upon further interrogation, they now took them to where the septic tank where they murdered and threw the guy inside. So you can see what visibility can cause. Assuming there was no visibility, for example, maybe that one would have just gone as that the guy disappeared. Then also emergency access. Is it something that fire service can come in quickly? Most of the issues with all the markets in Lagos, whenever there's fire service cannot even navigate what they will be able to access there. It's one big wahala because the place is overpopulated, poor road networks, and poorly planned. These are things you're putting into consideration in your site location. If emergency, evacuation, or rescue, or response has to be implemented, how accessible is it? Is the place prone to natural disasters, typhoons, earthquakes, tornadoes, then also flooding? What is the wind as well as surface traffic? This also helps, especially for network connectivity. Who are the tenants there as well? This is also very important for you to find out. One time we did one investigation in one bank. It was a microfinance bank. So they came in that morning, went into the vault to vault out cash. They now looked up and saw a tiny hole from their roof. The place was decking. And I said, what is happening now? Why is there? So that's how they went upstairs. There were 2 guys that were staying that upstairs. Say, sorry, we noticed it's like that our decking is collapsing. We noticed one small hole. You guys started making, people cannot enter my house. So that's how the police now stepped in, forced their way through. And I went to that place and discovered that these guys have been boring hole from their own apartment to access the bank's vault. So maybe they did work the previous night, but they didn't finish, hoping to now resume the following day. But they didn't know that they had already created a small hole, which was what gave them away. So you see, you need to also be careful about the tenants that you are sharing the facility with. Does the place have stable power supply? Is also another major consideration. Most of our IT equipment will need power. A lot of them are such that even a small fluctuation in power can cause damage. So that's part of the reason why you need to also put into consideration what's the power supply or what's the power stability like in that place. Then existing boundary protection. Are we sharing boundaries with another community, and the community, for example, we have boundary issues? That's also another thing. Then in terms of construction, places to pay special attention would include your floor slab, raised floor, your walls, ceiling, windows, doors. And like I mentioned, any place with a potential opening, of course, that place is vulnerability. Then for support facilities, HVAC, make sure you have heating, ventilation, and air conditioning. And for water, if you have water spillage, please turn off all electrical appliances on the equipment. Allow water to drain out of the equipment, place it in an air-conditioned room or area, then wipe with water displacement sprays. Electricity issues, it's better you install surge protectors, UPS to avoid interruptions, backup source for critical systems, maybe for example, generator. Then for earthquakes, you can take steps to reduce the impact of earthquakes by keeping computers away from glasses, windows, as well as high surfaces. You can also use anchors to hold your equipment so that they don't fall off on the computer. To protect lightning, the best practice is to switch the systems off and unplug them. Store backup tapes away from the building steel support. All of these are measures you can take to enhance heating, ventilation, and then other support facilities. Also, in terms of fire, as a security professional, you should also have a proper understanding of how to effectively deal with fire. There are different classes of fire, class A, class B, Class K, Class D, and then Class E fire. In Class A fire are combustibles, more like burning items, materials like paper, wood, furniture. Class B fire are fuel, like inert gasoline, petrol. Then Class C fire or Class E fire, electrical fires. Then Class D fire are what we now call special metals, maybe aluminum. Then Class K fire is kitchen fire. So these fires have also fire extinguishing methods or fire extinguishers that can work for them. So not all fire extinguishers will work for all types of fire. That's basically what we're saying in this case. For Class A, you can use water. For Class B, use inert gas as CO2. Same for Class C. But for electrical fire, please make sure you turn off the source of electricity first. Then for metal fire, use dry powder. And then for kitchen fire, you can use wet chemicals. These are also some other fire detection as well as suppression systems that you may choose to implement as a security professional. You can take a look at them much later. Things like smoke detectors, heat detectors, white pipe systems, then obviously your fire extinguishers. Power supply risk is also a major one, especially within the IT space. So you have different common types of fire or electrical problems. They include electrical faults like blackout. Blackout is where the light goes off completely. That's what we refer to as blackout. There's also brownout. And that's what we call low voltage in this part of the world. Dropout, it comes off and then goes on again. Then there are power faults like inrush, sag, transient, noise, and surge. We'll take a look at them here. So blackout, like I mentioned, is total loss of power. Brownout is a prolonged reduction in voltage below normal minimum specification. While dropout is a total loss of power for very short period. That's why I said it goes off and comes back almost immediately. Inrush, this is the instantaneous draw of current by a device when it is first switched on. While noise refers to random burst of small changes in voltage. Sag is a short drop in voltage, while surge is a prolonged increase in voltage. And transient is a brief oscillation in voltage, voltage going up and down. For your heating and ventilation, these are certain recommendations that CISSP says you can consider. Make sure that temperature and humidity are maintained within reasonable limits. Also, positive pressure and drainage are employed. Recommended humidity level should be between 40 to 55% because low humidity causes static electricity. High humidity can cause corrosion. Then for your AC, it is expected that you have a cooling system between 20 to 25 degrees centigrade. So don't go and put your AC and things will be chilling and people will be freezing. And you say, I'm living the life after all. No. Something between 20 to 25 degrees Celsius is very okay. And again, you cannot overemphasize the importance of training because if you notice, almost in all domains, it usually ends with the need for training and awareness, which is exactly what this is also advocating. So train personnel on operating emergency power systems, generator, backup powers. Also train them on how to use fire extinguishers, carry out fire drills, the evacuation routes. All of these should be prominently displayed. All of these are part of what your training program should contain. So here we're taking a look at, again, security engineering. Security engineering basically focuses on using models, frameworks, as well as architecture to effectively implement security within the organization. We first started by taking a look at some very popular frameworks, of course, including the SAPSA, the TOGAF, the ITIL, and then also the Zachman framework. We also took a look at various security models, the state machine, the multi-level lattice machine, part of which included the Bell-LaPadula confidentiality model, the Biba integrity model, the Clark-Wilson integrity model. Then also we took a look at evaluation criteria, TCSEC, then aside from that, we talked about ITSEC, then CC, which is common criteria. And then of course, we now talked about, again, need for physical security, because we said these are the heart of your security. Protecting your systems against natural, man-made, politically motivated, and supply disruptions. Said consider implementing crime prevention through environmental design, your site location. Key things for your site location, we talked about local crime, visibility, natural hazards, Then, of course, construction. We said areas you can focus attention on during construction can include your floors, your raised flooring, your ceilings, your windows, your doors. Then for your support facilities, your HVAC, we also mentioned things you can do to keep them at reasonable state. We also take a look at fire, measures you can take to be able to fight against some very popular types of fire. Note that for fire to take place, fire is a chemical reaction. So for fire to take place, three things have to be present: oxygen, source of heat, and then fuel. These are the three things that come together to make fire. So the idea is if you take away any of these things from the equation, fire goes off. If you take away heating or source of ignition, there won't be fire again. Or there's no oxygen. That's why sometimes we have what we refer to as a trap door, or those, fire doors. The idea is if there's fire in a room, if you lock the door, because fire will need oxygen. So once it exhausts all the oxygen in the room, it will die down naturally. Then aside from that, it needs a burning fuel. Fuel is basically anything that can burn, whether it's gasoline, whether it is a table, wood, paper, anything at all that can burn is what we call fuel. So to fight fire, take away any of these things from the equation. That's one of the things that the extinguishers do. Either they are suffocating the oxygen, which is where CO2 and then all the powders coming, or they are reducing the heat, which is where the lights of water forms coming. All these are measures we can take to be able to fight fire. Then we'll talk about electrical supply issues, and then the need for proper awareness and training. So this effectively brings us to the end of the third domain, which of course talks about security engineering. Thank you so much for watching. I hope this particular session has been very informative for you. Don't forget to like, comment, as well as share this particular video. You can also subscribe to my YouTube channel. You can also sign up as a member of this particular channel and you will be getting a whole lot of benefit as a member. You can also decide to sign up for any of our upcoming CISSP training or system security course, whether it is CISSP or CISA or CISM or CompTIA Security Plus. We are there to help you cover and most importantly, help you get certified at one sitting once you take the exam. In our next lesson, we shall take a look at the next domain, which is communications and network security.